Okay, chapter 7.7, or section 7.7, which is called the power of the point theorems. And there are three. We're going to take each one in a separate screencast. And as you see at the very top here, we have this thing called the power of the point. And what's really very cool, the power of the point, is a number associated with every point in the plane of a circle. So any point, in this case, let's think about C. C is drawn to two places on the circle. So we've got C drawn to G and to D and down here, okay? The product is called the power of those two distances is the same no matter where the point is. In other words, the product of this piece, this number, times the whole, right? Distance to G times distance to D is the power of the point, is the number. And that is preserved no matter where we are, because these two numbers multiplied will equal these two numbers multiplied. And in fact, any time I go from C to the circle, right, I'll get a number times the whole. Let's see if I can erase some of this junk so that we can do some work here. Okay, so the proof of this, again, just like you would expect, we have a result that has a product, and the tool to get there probably is ratios, and that means similarity. And in this case, you'd be right. So let's look at these triangles. We've got a couple of triangles going on inside here. And again, what we're trying to prove is that CG times CD, right, piece times whole, is equal to CK times CE, piece times whole. And then that number is preserved all the way around. You might have already picked up that these two angles right here are equal because they intercept the same arc, which is really exciting over here. So those are the same. And of course they share C. So let's establish the triangles that are similar. Triangle, let's see. C E G is similar to triangle, let's see, C D K, right? And from that, we end up with, again, those ratios. And again, if you need to do some review on similarity, go back to those screencasts. And in this case, we have, let's see, this piece, CG, right, is to CK. CG is to CK, the same way that, let's see, CG, that this long piece is to this long piece. CE is to CD. And when we cross multiply, we end up with the result that we are looking for right here. Isn't that cool? And here's the big piece. Pay attention. Let's put this in a different color. Purple. This is not piece times piece equals piece times piece. It is piece times whole is equal to piece times whole. Classic mistake. I'd like you not to make those mistakes, okay? So that's the 2 secant power theorem.